and welcome to the demo session of DataPower tutorial. Here, we will try to understand the basics of DataPower and the brief concepts around it. We will see some real-time use cases and a little snapshot of how DataPower service development would look like. The target audience would be anyone interested to learn integration of web services through DataPower. In this demo session, we would cover the concepts surrounding DataPower, what exactly is DataPower, the terms and concepts related to it, business scenarios, and a brief about DataPower services. Let's start with the buzzword SOA. SOA stands for Service-Oriented Architecture. Here in this diagram, we see there are some client applications and there are certain components. The client applications are accessing these backend components with the help of services via internet. And this is a peculiar example of service-oriented architecture or SOA. So in a nutshell, we can say a system architecture where services are provided to client applications through a communication protocol over a network is known as SOA. Here is a snapshot of the scenario without and with SOA. Let's assume these geometrical shapes mean some services. Say this triangular shape refers to a service that does the work of security processing. Another shape signifies routing and so on. Like another shape says transformation, another shape says schema validation. So, say a client wants to interact with a backend application. So, in the scenario where SOA is not present, all these services need to be present in the backend application, and the client will interact one-to-one with the backend application, with all the services replicated on the each and every component. Whereas in case of SOA, there is only one time when the services are created on some middleware bus, and the clients interact with the backend components via the bus using the services. In this way, the services creation redundance is waived off. At the same time, the complexity reduces by many folds. Also, it makes the services loose coupled. We will see more benefits of SOA in the further slides. Let's now see ESB. ESB stands for Enterprise Service Bus. What is the use or purpose of ESB? ESB provides a communication system between interacting components. So here in this diagram we see there are multiple components which need to interact with each other. So instead of interacting to each other point to point, they are doing it with the help of an ESB or Enterprise Service Bus. It is a middleware tool. So of course, since it lies between the components for interaction, it is known as a middleware tool. It makes it easy to change or add components. Let's see that in this previous diagram which we have seen. Say we want to make any change to any particular service. So in the absence of SOA, or you can say in the absence of this ESB or bus which is shown here, change in the service would be needed to be done on each component. This would increase the work and overhead manifold. But in the presence of SOA or in the presence of ESB, this change or addition or subtraction of the services has become very, very simple and easy, since it needs to be done just once on the ESB. This is what this third point says. Next, ESB provides a place to enforce security, logging, and monitoring. So, of course, in an enterprise solution, security, logging, and monitoring are the three things which need to be in place. And ESB provides all of this functionality very, very well. Also, ESB provides load balancing and failover. Let's now see data power as an ESB. So what is data power? Data power is nothing but an ESB in the form of a network appliance. Network appliance means a device. So data power is a physical device. It is an ESB in the form of a network appliance. Data power provides protocol independent message brokery, which means it provides protocol virtualization. What this signifies is, say a front end is sending a request in the form of HTTP, whereas the backend component accepts a request only via MQ and not HTTP. In that case, data power would act as an ESB or as a mediator between the front end and the back end, and it would virtualize the protocol. Data power would accept the request in the form of HTTP from the client. It will do the transformations and manipulations whichever is required by the business and send the request back to the provider via MQ. But the front end or the client would not be aware of this backend transfer of message via MQ, and hence protocol has been virtualized. Next, DataPower also provides message virtualization and endpoint virtualization. What message and endpoint virtualization mean is, first, message virtualization. Say a front end sends message in one format and the back end receives message in another format. So DataPower does the conversion of messages from one format to another and hence virtualizes the message. At the same time, endpoint virtualization, which means say the provider does not want to expose its endpoint to the front end. So it will take help of DataPower to do endpoint virtualization. DataPower would expose its proxy endpoint to the sorry to the client. The client will send requests to the endpoint sent by DataPower. DataPower will in turn route that message to the actual backend provider endpoint. In this way, the endpoint has been virtualized to the front. Also, apart from virtualization, DataPower provides XML processing at near wire speed. What it means is, DataPower processes the XML data, which is one of the most widely used formats of transfer of data in the web services, at near wire speed. And this is the reason why data power is very much favored among the different ESPs, because nowadays in the bulky XML transactions, the processing speed matters a lot. And there are multiple ESPs which do provide XML transformation, but they at the same time slow down the transformation process due to the bulkiness of the XML messages or due to heavy traffic of XML messages. But DataPower has this quality of doing this XML processing at a very high and good, and at a very high and good speed. Next, what DataPower provides is collaboration between processes and information. So of course, DataPower is surrounded by processes and information, which it acts as a collaborator. Also, DataPower provides orchestration of business processes. Orchestration means routing the message to the intermediate services and doing manipulation to those messages and sending to the back. So this process of interacting with multiple interfaces, doing manipulation and routing the request to the current endpoints is known as orchestration, and very well handled by the data power in different business processes. And last but not the least, data power provides message security. So message security is one of the most important concerns of most of the businesses, and data power handles it very well. Data power provides security via encryption, decryption, digital signature, OAuth, AAA, SSL, and so on. And so DataPower is one of the most favored appliances for the purpose of ESP, as it provides a very high level of message security. So these are the basic DataPower features which make it one of the most powerful tools in the list of ESPs. We will see more in the main tutorial session. So DataPower is a device with its own firmware and no operating system. Many times people come with the question, is DataPower a software or a hardware? Actually, DataPower is a device, a physical device. It looks like a CPU, but not exactly of the same size. It is thinner than CPU and wider than CPU. It is a device with its own firmware, and here firmware has been defined as a software embedded in a hardware. Here we see DataPower does not have its operating system. In a legacy system which contains an operating system, multiple supporting files and applications need to be present in order for the operating system to run. But in DataPower, there is no such operating system or such supporting config file. There is just one config file, and whenever there is a need to change a configuration, the firmware needs to be upgraded with the latest config file, which is just one file inside this firmware. Also, DataPower does not have any floppy disk drive, CD-ROM drive, USB port, etc. It just has some Ethernet ports which look like USB ports, but not exactly USB ports. They are the Ethernet in DataPower device. Now, a DataPower use case. So we have already seen the basic uses of DataPower. So here we see DataPower is being used in a trusted domain. It is surrounded by application services and different systems. Our customer also is trying to access the system via DataPower. Here DataPower is also being used in a demilitarized zone or DMZ zone, as we say it. It is used for further security to the trusted domain before it is exposed to the internet or to the outside world or to the customer. So this introduction of DataPower in demilitarized zone is one of the features of DataPower. It provides a security gateway, intelligent content routing and load distribution, B2B partner gateway. These are the functions of DataPower in the demilitarized zone. And these are the basic features of DataPower, why it is used in the trust zone. So there is a double usage of DataPower to make it extra secure in any transaction, which includes the trading partners with consumers, mobile or on desktops. Here are some of the examples using DataPower for mobile use cases. So DataPower is, as I said, is a very widely used application which is being used by multiple domains. Large international bank has mobile banking that goes through DataPower. Large mobile company in the UK has traffic from handsets, REST service calls being secured via DataPower. So just like SOAP calls, there are REST calls which are used while doing the calls via mobile applications. Why do we use REST in the mobile is one thing in nutshell which we can say is um, since REST is one of the most lightweight protocols, that is why we use REST services while making mobile call via mobile applications. Also, let's move on. Large global phone company has their RESTful service calls using JSON and XML from mobile devices, and customer browsers are secured and load balanced using DataPower. So here we see apart from XML there is something called as JSON. So just like XML, JSON is also a format of sending messages across web services. And so we have a few more examples where data power is used. These are the different devices of data power in market. As I said, they look like CPU devices, but not exactly CPU. They have some Ethernet ports, etc. These are the different varieties of flavors of data power which are there in the market, which are used as service gateway appliance or integration appliance, which is of our interest, where we will do all the service development. And also as XML accelerator, security gateway, and few more. So all of them have got some name like XT45, XI52, XC35, XC40. DataPower was created by DataPower Technologies Incorporation, but later it was acquired by IBM in 2005. So we see the label of IBM on all the DataPower boxes. Here are a few SOA specifications based on XML. So we know XML is a format which includes some tags, some fields, and the values of those fields. Is a very human readable and user friendly format of messages. So very much widely used on the web services. We have XML schema or XSD files, which are the rule books of XML. They describe the structure of XML documents using the XML syntax. So these themselves are XML files, but they specify what all fields will be present in the XML, what would be the root element, what would be the child element, what would be the data type of the elements, and so on. All of those information is present in XML schema. We have SOAP. SOAP is a protocol, simple object access protocol, which provides the standard structure for web service requests and response messages in XML format. We have WSDL, which is again like a rule book of the web service. So WSDL provides the language for defining the interface and binding the details of the web service. WSDL documents are XML documents. So of course, just like XML schema documents, WSDL are also the XML documents, but these uh, provide information like service name, the endpoint, the URL, the different bindings, the different formats of messages, what all operations would be used in the message. So all those things are defined in the WSDL file. Next, we have an XSLT file. It is a language of transforming XML documents to another format. So this is one of the core files which we need to learn while designing or while creating a web service. So it is a language which we use to transform any input or incoming XML file to an outgoing one. Next is an XPath. XPath is a platform-independent syntax for addressing parts of an XML document. So it's like XPath is like the regular expression, we can say, and it is used to define a particular field or particular node or attribute of a XML file. So, in order to understand um, the XML elements, we need to sure understand an XPath. Here are some of the domains where DataPower is used. As I said, DataPower is very widely used in a wide variety of domains like government agency, banking, insurance, healthcare, retail, telecom, airline, and so on. Let's peek into the DataPower components. When we log into DataPower while creating services, we will see here I'm showing only some snapshots. When we go through the actual DataPower tutorial, we will study each and every service and components of DataPower in detail on live DataPower boxes. So here are just the snapshots of those screens. This is what we see when we log into DataPower. Here is a control panel with multiple segments, one segment being of the services. So these are the different types of services which we can create in DataPower: web service proxy, multi-protocol gateway, XML firewall, and so on. So these services we will create based on the requirement and the data present with us before creating a service. Monitoring and troubleshooting is, as the name suggests, this will be used to monitor the health of the DataPower service and our DataPower device, and also while debugging the transactions. In file and administration, we have this file management folder, which is one of the most important things while creating DataPower service. So file management will contain all the XML related files like we studied here, XML schema or WSDL or XLT and so on. These things will be present in a file management folder. And there are many more things like here is a navigation panel, here is the firmware name. All those things we will see in detail in the DataPower tutorial session. Here is a snapshot of file management, what we saw over here. The file management, when we click on this icon, this is what will be displayed. These are the different folders, and each folder has a specific purpose. So which XML file or which certificate or which document needs to be kept where is prefixed. And there are some temporary files which get created that are stored over here. There are some certificates that need to be present in the certificate folder, and so on. Every folder has a specific purpose and use, and every document needs to be placed in the correct folder in correct order. Similarly, while we create a multi-protocol gateway, right? Multi-protocol gateway is one kind of this service which we saw over here, multi-protocol gateway. When we go to multi-protocol gateway and try to create a multi-protocol gateway service, this is how the page will look like. Here's the service name and the XML manager and so on. Some details we need to give, which we will study in detail. And this is how service flow looks like. So this is a policy, a rule. It has a request rule, a response rule, and these are the different actions present in the flow. How do we place these actions? What is the significance of each actions is what is the matter of study. Then working with DataPower is interesting and very much encouraged by the industry. So this was a short demo about DataPower, what DataPower is. I hope you